integrate. Okay, so for A, we need to integrate from 0 until 3, and the function is C for x minus x square dx and equal to 1. Okay, sebab ada satu function je, so diequalkan dengan 1. Okay, and you calculate C certain and we integrate for x. So we have for x square over 2 minus with integrate x square is x cube over 3 and limit 0 until 3 and equal to 1. Okay, and C, next you substitute with 3, so you will have 18. Okay, 18 minus with 27 over 3. Ini saya substitute value 3 ya. So minus with the 0 and equal to 1. Okay, and you get 9C equal to 1 and C is equal to 1 over 9. Okay, so you dapat C equal to 1 over 9. Next, for B, we need to find the probability of X less than equal to 3 but greater than 2. Okay, so saya use line number. First, you have 0 until 3. So, ini represent the original question. You have 0 until 3 and the function is C. So, C tadi kita calculate 1 over 9 and for X minus X square. Okay, and you need to find 2 until 3. So, for example, this one is 2 and then we have 3. So, we need to find this. Okay. So 2 until 3 ni still dalam interval yang ini. So you terus ambil je lah, yang ambil this function. So for B, okay, we need to integrate 2 until 3 and function is C 1 over 9 and for X minus with X square dx. Okay, so equal to 1 over 9 and you integrate for X square over 2 minus X cube over 3. You have 2 until 3. Okay, so this substitute value and next we have the final answer is equal to 11 over 27. Okay, so you have 11 over 27. Okay, so ini for B. Okay, last example for continuous radial variables, we have example 29. Okay, so for example 29, okay, so you have probability density function fx. So we have two functions kx and k4 minus x, and then the interval will also have 2, 0 until 2 and second is 2 until 4. For A, we need to find the value of k. So sama macam yang previous example 28. Okay, so kalau nak calculate value of k, mana you kena totalkan the integrations tu must equal to 1. Okay, so for A, you need to integrate from 0 until 2 and function kx dx plus with the second interval you have 2 until 4 and k 4 minus x dx. Okay, so equal to 1. Okay, so take out k, integrate x, we have x square over 2, 0 until 2. So plus with k and integrate 4, dapat 4x minus x square over 2. And we have 2 until 4 equal to 1. Okay, so nanti you boleh substitute value. Okay, so first substitute value with 2, you have k and 2 square over 2 minus 0. So plus with k. Next substitute with 4. For 4 minus with 4 square over 2. So substitute with 2. For 2 minus with 2 square over 2. Okay, so equal to 1. Okay, so exam ni you kena tunjuk step you substitute value ni. Okay, so dah ada markah kat sini. Okay, so after you substitute value and then you will get 2k plus 2k equal to 1 and you have 4k equal to 1, k is 1 over 4. Okay, so k you have 1 over 4. For B, we need to find, okay, B we need to sketch Okay, so question B, sketch the graph of fx. Okay, so sketch the graph for fx. First you need to identify lah, fx ni first function is a linear, second function also a linear function. So the graph must be a straight line. Okay, so for B, saya write down balik you punya equation. After you substitute k with 1/4, then the new function will becomes, you have 1/4x, 1/4x, and your limit is less than 2, greater than 0. Next, kita ada 1/4, 4 minus x. Okay. So yang ini represent x less than equal to 4 but greater than 2. Okay, and we have 0 for otherwise. Okay, so we need to sketch the graph. Macam biasa saya ambil pada endpoint dia. So ataupun you nak ambil pada every value pada interval pun boleh. Contoh saya ambil pada f0. F0 you akan dapat 1/4, 0, so equal to 0. And next you calculate pada F2. Ni saya ambil pada endpoint je sebab dia graph linear. Graph linear you perlu 2 point je. Nanti you boleh terus sketch graph. Okay. So F2 is 1/4, 2. So you will have 1/2. For second interval, saya choose value 2 and 4. So for F2, saya substitute dalam second interval. So 4 minus 2. And you will have 2/4 or 1/2. And last, saya substitute x dia with 4. So F4. So dalam second equation. So 4 minus 4 and you will have 0. Okay, lepas tu you boleh plot lah. Okay, you have x and you have 1. So x2 represent value for the interval. Kita ada 0, 1, 2, 3, 4. Okay, for function for axis y refer to the function fx. Okay, so when x equal to 0, so you will have 0, and when x is equal to 2, you will have 1/2. So you can dapat yang first graph. Okay, to sketch the second graph, okay, we have f2 also 1/2, so dapat kat sini 1/2. And for x is equal to 4, you dapat 0. So dapat 0. Okay, so yang ni represent the second graph. Okay, so you dapat yang graph for B lah. Tapi you boleh juga double check. Kalau you nak double check lah. Okay, you boleh double check value pada F1. So kalau you calculate pada F1, you substitute dalam first function, you will have 1. So you will have 1/4. Sama juga kalau you boleh check pada F3. So kalau you check pada F3, substitute dalam second function, you will have 1/4, 4 minus 3. Also you have 1/4. So you dapat 1/4 kat bawah. So fx equal to 1, 1/4 when x is equal to 3, also fx will be equal to 1/4. Okay, so ini graph for B. Next for C. C we need to find the probability x to 1 until 5. Okay, so saya refer balik you punya interval yang dia bagi. Kita ada 0 until 2 and 2 until 4. Okay, so from 0 until 2, the function is 1/4x. And from 2 until 4, the function is 1/4, 4 minus x. Okay, so for question C, we need to calculate probability x less and equal to 5 but greater than 2, greater than 1. Okay, so kita nak 1 until 5 lah. So kita ada 1 kat sini and 5. Okay, so kita nak this region. Okay, from 1 until 5. Okay, so you nak calculate create this region. Okay, so they also equal to, okay, first you integrate from 1 until 2. 1 until 2, you choose the first function, 1 over 4x dx, and plus with, okay, 2 until 4. And we have the second function, 4 minus x dx, and plus with 4 until 5. Okay, so 4 until 5, and then the function dia we consider as 0 lah, 0 dx. Sebab kita ada satu function yang untuk 0. 0 tu for otherwise. Otherwise tu selain daripada yang interval ni. So maknanya untuk 4 until 5, dia function ni is equal to 0. Okay, so you dapat set up the integral. Next you can integrate, lepas tu substitute value and you get the answer. Okay, so you have for C, so macam ni lah. Okay, so ini untuk yang first, second and third. So ni untuk 0. So 0 integrate, then we have 0. Okay, so ini you integrate lah, integrate, lepas tu substitute value. And we get the answer is equal to 7 over. Okay, so kita dah habis continuous random variables. Okay, ada soalan tak? Untuk continuous. Okay, tak ada Okay, so tak ada soalan. Ya, yeah, tak ada. Okay, so kalau tak ada soalan, saya nak continue with expectation of random variables. So expectation of random variables ni, dia sama juga macam mean. The mean of random variables. So mean tu kita dua, discrete and also for continuous. Okay, formula expected value or mean of discrete. Ni untuk formula discrete. Okay, we have EX. EX is the notation for the expected value. Formula dia is summation of the X times with the probability. Okay, and formula for expected value or mean of a continuous random variables, then we have EX, also notation the EX, but the formula is integrations of X times with the Fx. Okay, so X ni refer variable pada function F. For example, function F, variable dia is Y. So untuk yang X ni pun dia akan jadi Y jugalah. Okay, so ni formula for mean for discrete and continuous. So you kena hafal these two formula. Okay, so expected value ni senang je. Okay, so saya nak you refer to example 30. So example 30, so given is probability. So probability distribution function. So probability distribution function refer to the discrete. Okay, sebab kalau continuous dia density, probability density function. Okay, so ini for discrete, so you need to find the EX. So formula EX for discrete is summation of the X times with the probability. Okay, so equal to X to refer to values of X lah, with its own probability. Okay, so first X kita ada 1 and probability dia is 0.1. So plus with X2 and probability 0.5 and plus with X dia is 3 and probability 0.4. Okay, and you will have equal to 2.3. Okay, so ini formula for expected value for the discrete. Okay, next we have example 31. So example 31 refer to the probability density function. Okay, so example 31 is probability density function refer to the continuous random variables. Okay, so we need to find the expected value. So kalau you refer back the formula for expected value for continuous, dia equal to integrations of X times with Fx dx. Okay, so for example 31, okay, integrate tu you boleh refer je pada interval 1 until 3 and X you copy X and Fx. So Fx, you substitute function yang dibagi ni. So function ni is 1 over 4, 4 minus X, dx. Okay, so saya nak solve, saya take out 1 over 4 and you expand, you have 4x minus x square. Limit 1 until 3, okay, dx. Okay, so after you expand, then you need to integrate. So 1 over 4, 4x2 over 2 minus with x cubed over 3. Okay, limit 1 until 3. Okay, so nanti you substitute value lah. You substitute the upper and lower limit and you get the answer is equal to 11 over 6. Okay, so ini formula for the probability density function on how to calculate expected value. Okay, so you ada dua lah formula for expected. Satu untuk continuous, another one for discrete. Okay, now kita nak extend lagi. Extend into expectations of any function. Okay, for example, you have expectations of function gx. Okay, so gx can be 10x, x square or x minus 3 to the power of 3. Okay, so sebelum ni kita ada example, kita dah ada formula for ex. So kalau discrete, you ada x times with the probability. Okay, ni formula for discrete. And kalau ex for continuous, formula dia is x times with the fx dx. Okay, so formula ni dia apply kalau you punya x tu, you punya variable tu is only x. Okay, so beside x, you punya question can extend into 10x. For example, dia nak you calculate expected value for the 10x. Or dia nak you calculate ex square. So pun boleh, any function dia boleh tukar. Tapi kalau you nak calculate, you tukar jugalah. Modify you punya original function ni. So kalau kat sini x, this one pun will be x. So kalau you nak calculate E10x, kalau discrete, then jadi summation of the 10x lah. 10x times with the probability. So probability kita tak ubah, dia remain ya. Okay, you hanya ubah pada yang variable depan je. Okay, so kalau 10x, this one become 10x. So kalau this one is the x, and then the variable become x. Okay, sama juga ex square. For example, ex square tapi for continuous. So kalau continuous, this one x, and the variable is also x. Kalau ex square, then dia akan jadi x square lah. X square times with the function fx. So function fx kita tak ubah. Okay, dia sama je, tapi kita hanya ubah pada yang dekat depan ni. Okay, variables yang you nak multiply with the function fx. Okay, so ini formula on how to find the expectations of any function. Okay. Or you can also solve using rules of expectation. So kita ada dua cara macam mana you nak solve untuk expectation of any function. Contoh yang tadi lah, kalau you nak calculate for E10x. E10x, kalau you nak pakai formula, then dia jadi summation of the 10x times with the probability. Ni example kalau dia discrete. Sama juga kalau continuous. You nak calculate, dia akan jadi E10x, dia equal to integrations of 10x times with fx dx. Okay. So kalau you tak nak pakai formula, sebab formula ni mungkin dia boleh jadi panjang sebab you kena kira balik substitute value semua. You boleh juga solve using rules of expectation. Ni macam shortcut dia. Okay. For rules number 1, you have EA is equal to A. Means that, for example, you have E6 equal to 6. Okay. And for rules number 2, EAX. So ini dia boleh apply yang ni, yang example 10x ni. Or you can solve juga pakai rules. So E10x, kalau you apply rules, dia also equal to 10 times with the EX. So dia lagi senang nak kira lah. Okay. And for rules number 3, so ini also for example dia, you nak calculate E5x plus 1. Okay, so kalau you expand using rules of expectation, becomes 5ex plus with 1. Okay. Next rule number 4, yang ni for different variables. And this one, rules for number 5, also apply for the different variables. Okay. So saya nak you refer to example 34. 33. Okay, example 32 you can refer to recorded video. So saya nak move to example 33. Okay, so you can refer to example 33. A continuous random variable x has a probability density function. Okay, so you are given function fx equal to 5x to the power of 4, and then the interval is from 0 until 1. Okay, for A, we need to calculate what is the ex. Okay, so you need to calculate what is the ex. Okay, so for probability density function, formula for ex is equal to integrations of x times with the fx dx. So in this case, you have limit there from 0 until 1. Okay, so you have x with copy jx, and you multiply with the function. So function is 5x to the power of 4 dx. Okay, so you expand dulu 0 until 1, then we have 4x to the power of 5 dx. Okay, after you expand, then you can integrate 5x6 over 6. Okay, so you integrate limit 0 until 1. Okay, and you get the final answer is equal to 5 over 6. Okay, so ini for A. Okay, next for B. B, we need to solve for E2x. So E2x ni, dia boleh ada dua formula ataupun dua method you nak solve dia. First, you can integrate. So, kalau you nak integrate, maknanya dia akan jadi 0 until 1. Okay, 0 until 1, and then x ni we substitute as 2x. 2x times with 5x to the power of 4 dx. Jadi lebih kurang sama macam ni, tapi kat sini x, tapi so kalau e2x then become 2x lah. Okay, or so nanti you expand lah, lepas you integrate substitute value. Or you can use rules of expectation. Ni lagi senang. Kalau you nak calculate e2x, kalau you apply rules, dia also equal to 2ex. Okay, so substitute je ex, you dah calculate pada A, you have 5 over 6. So you get the answers is equal to 10 over 3. 10 over 6 or 5 over 3. Okay, e2x is 5 over 3. Ni saya solve using rules of expectation. And last for C. Okay, C we need to find ex square. Okay, for C, cuba kat sini C. C to find ex square. So ini saya pakai terus formula, tak pakai rules. Sebab rules untuk yang kalau ex square then you kena pakai formula, tak boleh pakai rules. So formula saya ambil 0 until 1, and then substitute x with x square, multiply with the fx. 5x to the power of 4 dx. Okay, so they also equal to 0 until 1, and you expand, you have 5x to the power of 6 dx. Okay, so nanti you integrate, substitute value, and you get the final answer is equal to 5 over 7. Okay, so yang ni answers for C lah, for ex square. Okay, okay, next kita ada example 34. Okay, so you can refer to example 34. Okay, so the random variable x has mean 2. So kalau mean ni sama dengan expected value. So dia dah bagi lah given ex is equal to 2 or mean is equal to 2. Okay, for A we need to find E3. So ni kalau you refer balik rules number 1, E3 also equal to 3. Okay, and for B we need to find E5x. Okay, so saya apply rules. E5x also equal to 5ex. Okay, so equal to 5. Ex substitute with 2 and you get answers is equal to 10. Okay, and last for C, you have E 5x minus 3. Okay, so saya apply rules juga. Dia also equal to 5 ex minus with e3. Okay, they also equal to 5ex. E3 is equal to 3. Okay, 5ex minus 3. And we have ex is 3 minus 3. So 15 minus 3 and then we will have E2, oh sorry, you need 2 ex substitute with 2. So 10 minus 3 and we have 7. Okay. So ni semua saya solve using rules of expected values. Okay. So ni for example 34. Next we'll have example 35. Okay. So saya nak move to example 35. Okay, so 35 include two variables. You have x and y. Okay, so x and y are independent variables such that ex ataupun mean is equal to 4, mean for x is equal to 4 and ey or mean y is equal to 5. Okay, find e to x plus 6y. Ni you boleh refer to rules lah, rules yang last sekali, number 5. Okay. So, sudah solve for A, kita ada e to x plus 6y. So, also equal to, saya apply rules, you can dapat e 2ex plus with 6ey. Okay. So, equal to 2, ex is 4 plus with 6, ey is 5. And you will have 38. Okay. And for B, we need to find E7x minus 4y. Okay, so also saya apply rules equal to 7ex minus 4ey. Okay, so equal to 7 times with ex, kita ada 4 minus with 4 times with ey, we have 5. So 28 minus 20 and answer is equal to 8. Okay, so ni example 34 and 35. Okay, so kita dah habis expected values. Okay, ada soalan tak? Before we proceed with variance. Okay, tak ada. So kalau tak ada soalan, saya nak continue with variance. Okay, so variance pun senang je. Dia apply balik formula for expected value. Okay, so 7.9. Okay, variance of random variables. So variance tadi kita ada mean. Mean dia ada untuk discrete and continuous. So dia pakai different formula. Kalau untuk mean untuk discrete, formula dia is summation of the x times with the probability. So ni untuk discrete. For continuous, formula for mean or expected value is integrations of x times with fx dx. Okay, so untuk mean dia ada different value for continuous or and discrete. Tapi for variance, dia hanya ada satu je formula. So the formula for variance tu, dia apply for both lah, untuk continuous and also for discrete. Okay, so ini formula dia. Okay, so formula for variance is equal to ex square minus with ex and then the whole terms tu with power with 2. So from variance also we can calculate standard deviation. So standard deviation is equal to set of the variance. So you kena hafal juga ni formula for the variance. Okay, so formula ni untuk dua-dua, untuk discrete and also for continuous random variables. Okay, so saya nak you refer to example 37. Okay, so ni example on how to find the variance. Okay, so tadi formula for variance, you have variance x equal to ex square minus with ex. Okay, so semua ex tu you need to squarekan dia. Okay, so in order to find the variance, first you need to have ex and also ex square. Okay, so for A, you calculate dulu ex. Okay, ex is equal to summation of the x times with the probability. Okay, ni expected yang tadi lah, formula yang tadi. So you multiply je 0 times 0.1, so plus with 1 times 0.2 plus 2 times 0.4 plus with 3 times 0.2. And you get the answer ex is equal to 2. Okay, next for B. B, you need to find the variance. So in order to find variance, you need to have ex. So ex you dah ada from A. Okay, so you need to calculate ex square dulu. Okay, so saya calculate first ex square. So ex square ni saya pakai formula juga. So summation of the x square times with the probability. Okay, so equal to x square, maknanya semua x tu you need to square kan dia. 0 square times 0.1, so probability tak ubah you hanya ubah pada x je. So ni 1 square times 0.2, so plus with 2 square times 0.4 plus with 3 square times 0.2. Okay, so nanti you calculate and you will get ex square is equal to 5.2. Okay, so you already have ex and ex square. So after you have these two values, then you can substitute into the formula for the variance. Okay, so saya proceed with the variance.
Madam,
Okay, so saya letak dekat
yang
atas. Yeah.
Madam, example ni Madam tertinggal
Yeah.
4. Ya, example 37 ni.
39. Oh, betul-betul. Sorry, so kita ada 4 0.1.
So, B pun
answer
sama.
betul kan tu?
Betul-betul.
Apa dia? So sudah betul kan tu? So ni
Betul.
pun sama untuk ex ni pun ex square ada tertinggal juga. Okay, so plus with 4 square. 4 square 0.1. So saya nampak yang ujung ni macam total dia. Okay, so untuk ex square you kena ambil semua x dia start pada 0 until 4. Untuk ex square pun sama 0 until 4. So untuk ex square function betul access dia. So you dapat 5.2. Okay, so you dah ada ex dengan ex square, then kita calculate variance. Okay, so nak calculate variance equal to ex square. So for ex square kita dah ada 5.2 minus with ex. So ex kita ada 2. 2, lepas tu you need to square kan ex. So square tu hanya untuk ex Nanti you akan dapat 5.2 minus 4 lah. 5.2 minus 4 and we get the final answer is equal to 1.2. Okay, so ni answers for variance. Okay, variance dia 1.2, mean dia is 2. Okay, so ini for example. So example 37 ni example on how to find the variance for discrete. So untuk discrete So kita nak tengok example untuk continuous pula. Okay, so untuk continuous, you can refer example 38. Okay, so we have probability density function. Okay, function dia is 30 x to the power of 4 times 1 minus x. Okay, so interval 0 until 1. Okay, first dia nak you calculate ex. Okay, so solution for A, ex, ni you kena refer balik formula for expected value for continuous. You have integrations of x times with the fx dx. Okay, so equal to, masuk je limit dia, limit 0 until 1 and you have x times with the function 30 x power 4 and 1 minus x dx. Okay, so nanti you simplify dulu. So you have 0 until 1. So kalau saya simplify and then it will become 30 and 30, lepas tu you ada x power 5 minus with x power 6. So x power 5 minus x power 6 dx. So nanti kita nak integrate 30 ni you boleh bawa keluar pun boleh. So ada constant. So 30, nanti you integrate x power of 5 is x6 over 6 minus with x7 over 7. And you substitute limit 0 until 1. So nanti you substitute lah upper lower limit and you get the answer is equal to 5 over 7. So yang ni for EX. Formula for EX or mean. For B. B dia nak EX square. So sama juga teknik dia. So B, you need to find EX square. So you boleh refer yang ni. Kalau EX, then this one will be X. Kalau EX square, then the formula becomes X square times with the Fx dx. So Fx tu you tak ubah ya. Fx tu still you punya function. Kita hanya ubah yang dekat depan je. So nanti limit pun sama, kita tak ubah. You ambil 0 until 1. So you have X square times with the function Fx. So function Fx is the dx to the power of 4. 1 minus x dx. Next you simplify dulu. You have 0 until 1 and 30. You have x power 6 minus with x power 7. You have dx. X power 6 minus x power 7. Lepas tu you integrate 30, so integrate x power 6, you have x7 over 7 minus x8 over 8. So limit 0 until 1. So nanti substitute the upper and lower limit and you get the final answer is equal to 15 over 28. So you dah dapat dah EX and EX square. 15 over 28. So last dia nak you calculate what is the variance. So to calculate variance equal to formula is EX square minus with EX square. So formula variance for continuous sama je formula untuk discrete. So substitute je EX square tadi kita dah calculate, you have 15 over 28. So 15 over 28 minus with EX kita ada tadi 5 over 7. So minus 5 over 7 square. So nanti you calculate equal to 5 over 196. So yang ni refer to the variance. So kita dah tengoklah example on how to calculate variance for discrete and also calculation of the variance for continuous random variables. So kita nak tengok rules pula. Rules for variance. Tadi kita ada rules for EX. Rules for EX tadi kita ada 5 rules dia. Next kita ada also rules for variance. Ini pun you boleh hafal jugalah. Mungkin senang you nak kira dia. So ni rules for variance. So kalau rules for variance, kalau variance A, so A ni can be any numbers that is equal to 0. Contoh kalau you ada variance 6, dia akan equal to 0. So the difference compared to formula for EX. So kalau formula for expected value, kalau you ada E6, dia akan equal to 6. Yang ni untuk EX, this one for variance. Variance mana kalau ini numbers dah akan jadi 0. Lepas tu untuk second formula, untuk variance AX. Variance AX can be example, contoh variance 3X. So variance 3X, kalau you pakai rules dia also equal to 3 square. So you kena squarekan 3 tu, baru you multiply with the variance. Okay. Next, formula number 3, you have example variant 3x plus 1. Okay, they also equal to 3 power 2 variance x. So yang B dia tak ada, dia terus remove jadi 0. Sebab dia sebenarnya pluskan dengan variance 1. So variance 1 is 0. So you akan dapat 3 square variance x je. So kalau tengok formula C dengan yang B ni sama je. Okay, sebab yang B belakang ni dia terus remove, dia jadi 0. Okay, so tu dapat formula yang sama for B and C. Okay, so kalau formula number 4, when in the random variables involve two variables, kita ada X and Y. So you separatekan je lah nak calculate variance dia. Or you have yang last formula ni ataupun yang rules yang last ni, for example kita ada variance 3X plus with 2Y. Okay, so you boleh simplify dia into 3 square variant X plus with 2 square variance 1. Okay. So ini for rules for variance lah. So you jangan confuse dengan rules for EX ataupun rules for expected value. Okay. Okay. So example 39 ni you tengok di kodok video saya nak tunjuk you the difference. So takut you confuse dengan EX. So kalau formula for EX dengan formula for the variance. Okay, so kalau EX, for example, you nak calculate E3. So E3 and then you will have 3 lah. Kalau variance, you ada variance 3, dia akan jadi equal to 0. Okay, so kalau you ada numbers, dia automatic jadi 0. Kalau ni untuk expected value. Okay, untuk rules number 2, for example, kita ada E5X. Dia akan equal to 5EX. Okay, so ni untuk mean. Kalau variance, the formula, the rules become variant 5x. Okay, so dia akan jadi 5 square. Dia take out juga 5 tu, tapi you kena squarekan 5 and next multiply with the variance x. Okay, and also we have the third formula. Contoh kita ada E 5x plus 2. So kalau untuk EX dia akan jadi 5EX plus with E2. Okay. So dia akan dapat E2 is 2. So dia akan dapat 5EX plus 2. So E2 ni dia apply balik yang rules number 1 tadi. Number 1, number 2, number 3. Okay. Kalau variance, contoh you nak calculate variance 5X plus 2. Dia also equal to 5 square variant x plus with variance 2. So variance 2 dia akan apply balik yang rules number 1, dia akan jadi 0. So dia also equal to 5 square variant x plus with 0. Okay, so ni yang 3 rules lah. Kalau dia involve one variable, so kalau 2 variables pun dia apply benda yang sama. Okay, so yang untuk number 1, okay, kalau di constant dan dia dapat untuk EX dapat 3. So kalau variance dia akan dapat 0. Okay, kalau rules number 2 untuk EX, 5 tu you can take out the 5 and then multiply with EX. Kalau untuk variance, konsep dia sama, you take out 5 tapi you kena square kan. So jangan lupa square kan untuk variance. Untuk yang third formula pun sama. So kita ada 5, so you take out 5 dapat 5EX plus 2. Tapi kalau untuk variance, dia akan dapat sama macam yang formula number 2. So kalau you tengok untuk formula number 2 ni ataupun rules number 2, dia apply sama dengan rules number 3. Okay, sebab yang belakang ni automatic dia jadi 0. Okay, so dia lain dengan EX. EX yang 2 ni still kita kira consider dia ada value. Okay, so ini the difference lah between rules for expected value or rules for mean and also rules for variance. Okay, so kita stop dulu kat sini. Okay, nanti next week saya akan habiskan chapter 7. So chapter 7 kita tinggal lagi 2 je example. Lepas tu kita akan terus masuk chapter 8 lah, yang last chapter. Okay, so ada apa soalan? Tak ada. So kalau tak ada soalan, kita continue next week. Okay, so assignment pun kalau ada soalan you boleh WhatsApp saya. Okay, so tu je untuk hari ni. Thank you class.
Okay, madam.